We're going to move on to our 2024 striped bass stock assessment. We're going to have a presentation from Dr. Gary Nelson to provide an overview of the assessment report. So I will pass it over to Dr. Gary Nelson.
Thank you, Madam Chair. We have 4 tours that we're going to show you today. So we completed the stock assessment update this past August. Katie and Mike Celestino were partners in assembling all the data, and I just get it all and push the buttons. So this is what I'm going to show you today. So so tour one is to update the fisheries dependent data, which include the landings, discards, catch at age data that we used in the previous peer review and accepted benchmark stock assessment. So we did that. We updated the data from 22 and 23 using all the MRIP and harvest numbers and releases to calculate the dead releases. All the states were updated. If you're unfamiliar with what we do, it's pretty much using the estimates for all states except for North Carolina. We just use any of the numbers that they generate for the ocean only. For the commercial harvest, we got the information from Mass, Rhode Island, New York, Delaware, Maryland, PRFC, Virginia, and then North Carolina in the ocean only. And then we updated the commercial discard estimates, and in that method, we use tag data along with the MRIP data to come up with commercial discards. And just to point out, we are missing data in the summary. We don't include catches from major rivers like the Hudson or Delaware because the MRIP program does not go that far up those rivers. And of course, there's always things like poaching that we don't have good estimates for. There we go. So in this slide, I'm showing up on the screen now, shows the total numbers of removals for the whole time series, 1982 up to 2003. It's broken down by into the Bay fleet. We use what's called a area as fleets modeling approach. And so we have the information broke down into the Bay and the ocean. The Bay here is in gray and the ocean is in blue. The total, the total estimates, as you can see, I highlighted an arrow up there, and that was the increase in the catches in 2022, which prompted the emergency action that we did in 2023. And for the Bay in 2022, the total removals was 1.58 million fish and 1.42 million fish in 2003. And on the ocean, it was 5.2 million in 2022 and 4.2 million in 2023, giving us a total of 6.79 million fish in 2022 and 5.58 million in 2023. And the bump up in 2002 was mostly from the ocean. This slide shows kind of the same thing, the total removals, but broken down by disposition. Here we have, here we show that the recreational dead releases and the recreational harvest make up about 89% of all the removals on the coast. The commercial harvest made up roughly 11%, and the commercial discards, and this was in 2003, sorry, and commercial discards were less than a percent. Okay, and then just showing the total catch or total removals age composition, just to show you some highlights in the year classes that are moving through. If I can see the colors here. In orange is the old 2011 year class that you could see that moved through starting in 2012 and is no longer early in the catch at age in very low numbers. The next big one was 2015. This is from Chesapeake Bay. There was a 2014, which I think came from Hudson River. You can see both of those moving through. And then now in 2023, the 2015 is age 8. And then we have the just slightly below average 2018 year class in green here, just coming into the landings. And this year, 2023, about age 5. And those should be passing through the fishery pretty well in 2024. Tour 2, it was basically to update the fisheries independent data, which we use in the stock assessment to tune the information. So I'll just briefly go over some slides of the different indices we use. It's hard to see, so we're going to stop in the upper left-hand corner. Within the stock assessment, we develop a method of combining the Maryland Young of the Year and Virginia Young of the Year into one index, and we call that the composite index. And that's shown in the upper left graph. As you can see, in the last few years, the index is showing a steep drop. And then below that is actually the Maryland Young of the Year out to 1957. I think that's 57. Yeah, showing the actual values from that index alone, and you can see those bummer year classes that we've been having the last few years are way down. And then the Virginia index showed also a drop in the last few years. Up in the upper right-hand corner is the New Jersey Delaware Bay index. They missed and they didn't do it in 2020, I think. And but since then, their index has been dropping also. And then in the New York JAI, which is one below that, 2023 seemed to be a clunker every year there. All right, so, and then we have a couple of indices that, so for the Young of the Year indices, we actually lag ahead 1 year and match those up to what would be age 1. And then we have the age 1 indices, which we lag ahead and a model with age 2 fish. So I know that's confusing. So we have 2 age 1 indices, one from Maryland and one from New York. And the Maryland's index is quite bouncy, but does show some of the strong year classes. I just noted the 2015 up here and 2018, and the rest have been kind of just bouncing around. And then the 2014, the New York index showing that big spike. That's the one below. That was the 2014 year class. But since then, they've had a pretty low abundance in the age 1s also. Within the model, we also have a bunch of indices, which we call the age composition indices, which have age data associated with them. And we model those age compositions along with the total index for each of these surveys. And up in the upper left-hand corner, starting with the CHESMAP survey, you can see there's been a decline in the last few years. I couldn't tell you offhand what ages those are right now, but there's definitely been a decline. The one below that's the Delaware 30-foot trawl, showing that the last few years has been very, very low. Also the New Jersey offshore trawl survey, which took a few years off and started back in 2022. And their indices, eventually they caught 0 fish the last couple of years. And then Connecticut at the bottom has been, up and down, but hasn't really dropped that much. Up in the upper right-hand corner is the Maryland spawning stock gillnet numbers. That's an index that's always been just flat and bouncing around, although within the data, the age composition actually does show changes over time. And next one is the Delaware spawning stock biomass, that's an electrofishing survey, and their indices have been going down. The New York Ocean Hull survey stopped in 2007, so there's no new data then. And then the other index is the MRIP, catch per unit effort index. These index just showing last few years have just been kind of flat and fluctuating. Okay, tour 3. This is to list the history of information used in assessment and or model parameterization and note any differences from the benchmark. So just to remind you, the benchmark model is known as forward projecting statistical catch at age model. We modeled the age 1 abundance using all those indices. And we include age classes up to 15 plus, and 15 being the plus group. We estimate fully recruited Fs for each year. We have at least 4 time blocks, which we estimate selectivity patterns in each. We have to estimate, because we have what, 14 indices within the model, we estimate 14 parameters, catchability parameters for them. And then we have selectivities that we estimate for 8 of the age composition surveys. The data are split into fleets, again, the ocean fleet and the bay fleet. And that was done to improve the estimates of selectivity, and they provide at least partial S, so you can check out the Fs in the bay as opposed to the ocean. And in the model, we use age-specific Ms, and those are used in the updates. We also use all the same information like the maturity at age schedules and sex ratio schedules. There we go. And we updated the weights at age to calculate the spawning stock biomass. And then we use the same methods to balance the data composition with contributions within the model. And I don't need to really get into that. For this assessment, we did a couple of runs initially. Because we have 2023 was the first year of the emergency action. It requires a new selectivity block because with the significant changes that were made. So we did initially 2 models in which we had a single time block for which we included 2020 to 2023 in and estimated the model based on that single time block. And then we actually had a model in which we had 2023 as its own time block, because we realized that the selectivity was going to change because of the regulations. However, so we brought those 2 models to the TC, and there were some issues with both, and the TC was uncomfortable with the 2 time block model. The one when 2023 has its own time block, and the reason for that was because there's really only 1 year to estimate selectivity from, and you probably should have at least 2 or 3 years to come up with some good estimates of selectivity. And looking at the output from that model, looking at the selectivity, the TC was concerned that actually the descending limb of this selectivity pattern was steeper than would have been expected based on just a reduction of 4 inches down to 31. And actually the curve have shifted to older ages, where if we're cutting down to a smaller size, it should be shifting to the left. So the TC did not think that model with the 2 time blocks was appropriate for stock determination because of that uncertainty in the selectivity for 2023. So for determining status, they all proved that the single time block model was the best one for now. And those are the results that I will be presenting. And we can get into, I get slides later showing you some of the issues with that alternative run with a 2 time block model. So tour 4, update accepted model and estimate uncertainty, do some retrospective analysis, include sensitivity runs, and compare the benchmark assessment results. So these are the results for that single time block model. This slide just shows the fully recruited F by the different fleets, the Bay and Ocean, which are, if I can see the colors, yellow is the Ocean, blue is the Bay, and then the total F for both areas combined is in the top black. You can see from going from 2021, we had a jump up in F in the Ocean in the total to 2022 and 2023. Let's see what else. But the in Chesapeake Bay, F kind of remained flat for the last few years. This slide just shows the estimates of recruitment, the H1 numbers. In the slide, there's a horizontal dashed line that just shows the time series mean. And I've highlighted several of the large year classes that we've talked about over the last few years, the 2011, 2015, and then the 2018 out of Chesapeake Bay, showing their magnitude here. And notice that the last few years, 2022 and 2023 are low, excuse me. Let's see, recruitment has declined since 2018, looking at that trend. Let's see. This slide on the upper slide is the estimates of total abundance, that's all ages. And below that, excuse me, is the age 8+ abundance. You can see the abundance was highest in looked like 1990s or so, and then declined a bit and have declined since, not so in a steep manner, but last few years it definitely has done that. And then the 8+ abundances kind of reflect what we've seen in the SSB, which we had this decline since the 2012 or so, but the new model estimates suggest that the 8+ abundance is increasing. And this just shows, the slide just shows the female spawning stock biomass on the top and exploitable biomass on the bottom. The female spawning stock biomass for 2022 and 23 show it has increased. So it jumped up, and this is probably primarily due to the 2015 year class starting to move through the fishery, or at least into the spawning stock ages, which females start about age 7. And then below that is the exploitable biomass. This is just the vulnerable biomass if we allowed, if I remember correctly, allowed us to fish on everything, right? Something like that. And some retrospective analysis. So in retrospective analysis are used to examine the stability of our terminal estimates, our current estimates of fishing mortality and spawning stock biomass by removing essentially 1 year of data, keeping the configuration that you put together for the current year, like 2024 for this assessment, then removing 1 year of data back in time and comparing the estimates. And what is shown up here for fishing mortality on the top and female spawning mortality on the bottom is that we do a fairly good job at estimating both. It seems that fishing mortality tends to be slightly underestimated, about, if I remember correctly, about 2%, 3% at this time. And then at the bottom is the differences. Oh, sorry, I forgot to mention. The slide on the right shows percent differences, the difference between our current measures, our current stock estimates, and then compared to the estimates that come out when you remove 1 year of data. And basically, we're slightly overestimating female spawning stock biomass in the current year. So we're doing pretty good. It tends to be under about 5% or so. Since there is, we're always concerned if there's a retrospective bias pattern, whether we should correct it or not. And the National Marine Fisheries Service uses a technique where they you look at the 90% confidence intervals of your current estimates, and then do some bias correction based on the pattern in the retrospective. And if that adjustment lies outside any of the 90% confidence intervals, then they tend to adjust the F and the SSB for the bias. In our case, there was very little, so there was no need for adjustment. So our estimates, the resulting estimates that came out are the ones that we use to determine stock status. We did some sensitivity runs, and primarily, excuse me, primarily I'm just going to show you in this section the differences in the selectivity that came out between that base model, which is the one-time block model, and then the alternate model, which included 2023 as its separate time block and selectivity. And at the top, you have to look at this going across. So on the top row, on the left are the estimates of what the selectivity would be for year 2020 and 23. And because they're in the same time block, up top, they're going to be the same selectivity. So on the left column is the bay selectivity, and on the right is the selectivity for the ocean. On the bottom row is the selectivities for that alternate model where we have 20 to 2022, a single time block, and 2023, its own time block. And you can see quite a difference you can compare across the different models. What I wanted to point out was the problem I mentioned earlier, why the TC didn't like this method was in the bottom right-hand corner, you can see the selectivity in the black for 2022, and then compare that to the estimate for 2023. And you can see how it shifted to older ages. And the slope of, on the right-hand side, the decline was much steeper than we expect from just a 4-inch change in the regulation. So that's why we decided to go with the single time block model as for the determination of status. And just for some comparisons, there's really, this is a slides that just show comparing the fully recruited F, the female spawning stock biomass, and recruitment values from those two models, the base and the alternate, showing there's very little difference except at the terminal year. Whoops, I don't have a pointer. If you look at the F for the alternate model, that went up as opposed to the base model, which actually went down, and there's very little difference between the two models. And let's see, and shown here are just comparisons of the spawning stock biomass on the top, the full Fs in the middle, and then recruitment at the bottom, comparing the estimates for the current model, which is in black here, and then the 2022 update, and then the benchmark done back in 2018. And They vary a little bit, but the trends have been pretty much the same. And 2.5, so we need to update the biological reference points for the stock and determine stock status. So our current reference point is actually for the female spawning stock biomass threshold is actually the 1995 value that the model estimates. That is the biomass threshold. And then for our target, we multiply that number by 125% to get what our target SSB should be. And from using those values, we then use a stochastic projection method to develop what the F threshold, the fully recruited fishing threshold, would have to be to get each of those values, either the threshold, SSB, or the F target. And the values that we use are pretty close to what we used that were determined back in the 2022 update. F threshold here is 0.21 and the target is 0.17. So conclusion. So based on, and this slide shows, in the upper slide is the female spawning stock biomass. The shaded areas, I believe the 95% confidence interval. And then the horizontal dashed line is the target SSB level, and the solid horizontal line is the threshold. You can see that we're still just a little bit below the threshold, SSB threshold. So because of this, the stock is determined to be overfished. But if we look at the fishing mortality below, since the F is below the threshold and close to the target, then overfishing is not occurring. So same status as it was in 2020. Questions?